All right, let's get things moving. It's day 85 of 100 Days of ML. And today I'm going to be continuing with paper a week, the Rashmon curves and volumes. Specifically, I think I'm starting to get into the meat of the paper. I think for the past 2 days, I've just been reading the introduction and abstract. So let's see. Okay, so I guess I was wrong. Um, So section 3 apparently is the Rashmon set definition and notation. So most of the section is just setting up the rest of the paper by introducing the set notations that are going to be used in a lot of the equations that are going to pop up during the paper. But yeah, okay. So I'll start out with this, see how it goes, because the notations do look a little more complex than what I'm used to. So it might be hard to understand everything clearly. I could check out the referenced papers and go through that path as well if I'm unable to understand the notations. Okay, what I can do is get the paper loaded up on screen. I'm going to follow the usual standard format where I just read a section, and at the end I'm just going to summarize it real quickly and then conclude, and that would be it for the stream for today. And tomorrow, I think probably going to continue with wherever I leave off today, depending on how much I can decode the notations. Looking into the paper, like further down the line, the math does seem pretty heavy. But I think it will be a good, interesting, learning curve. I think this is exactly why I want to do paper a week, to understand these notations and develop a consensus on how to approach ML problems. Okay, so here we go. This is the set definitions and notations. So yeah, I'll just start at it, see how it goes, and then depending on my progress, we'll see what to do next. All right, I'll go ahead and mute my mic and begin annotating the paper on my iPad. All right. So, I mean, I understand the definitions, but I don't think I understand the mathematics behind it just yet. Some of them seem pretty easy, like the fact that, empirical risk is given here, the true risk is given here, and the empirical risk is just the average of it. And you can see the summation being taken with division over n um, values. So that's just average of the true risk. However, I don't really understand what this e function is. I don't know if it's the um, I forgot what it's called, like estimator or something. E function and probability. E and probability. Um, Expected value, is that what it is? Is that what I'm thinking about? Expectation, I think. Yeah, expectation. It's the ability for to count, like if it's like one or if it's zero, you count the number of instances, and then you can take that as a true risk. But I'm not sure if that's what's going on here. Um, so a little confusing to understand. I understand the verbal definitions, but not the mathematical definitions just yet. Um, Next up, it defines the Rashmon ratio, which sets up the ratio of the volume of the models versus the hypothesis space. And so basically, this mathematical value, this ratio, whatever it comes out to, if it's high, close to one, it just means that there's a lot of models that can perform equally well. And closer it is to zero, it just means that there's a big variance in the model performance from the different models. So it is considered on multiplicity of models, and it works on a fixed data set. So what they do is compare it with different generalization metrics. For example, VC dimension, algorithmic stability, geometric margins. I have no idea how any of these complexity measures work. However, um, they just describe like what the differences are, and not too sure like what difference it makes, like if it's dependent on data or if it considers multiplicity of models. But I guess I'll just continue with this for now and see where it takes me. Like notations like this, it's like really hard to understand like where it's coming from, especially to like have a visual understanding and a conceptual understanding. I mean, from an algebraic standpoint, it makes sense. Okay, whatever, we're taking the log of the what is this hypothesis space? I believe F is hypothesis space. Yeah, but like, why are we doing that, and what's the significance? Like those questions are pretty hard to understand, especially when we're trying to decode like equations that are really long and complex. Trying to understand every single section of the equation is a task in itself. So what I might do is just get like a rough idea of what Rashomon curves are. Instead of reading the entire paper, I might just read like an article, and in addition, I'll also learn what the other generalization metrics are. So I think tomorrow that's what I'll do. Gonna wrap things up for today. So H3 day A6. What exactly are they called? Like model metrics or something? Complexity measures. The heck are complexity measures? Okay. It's just a definition of comparing multiple models. I think it was also introduced in related work somewhere here. Model selection. Estimating the complexity of each hypothesis space within a hierarchy. I'm just going to call it complexity measures. Okay, so that'll be it for today. I'll continue tomorrow.